Good afternoon, everyone, and thank you for joining us. My name is Dean Lees. I'm part of the engineering team at Buckley Associates. Today, we're going to be talking about smartIAQ from GPS Air. Our presenter is Tim Boyd, General Manager from GPS. And we're going to be talking specifically about how to reduce indoor air ventilation rates through using the ASHRAE-62.1 IAQP procedure. Most people here are probably familiar or more familiar with the VRP method in 62.1. But there's been new devices that have come onto the market and new commentary in ASHRAE that is seeing more and more people shift towards that different procedure and reduce ventilation rates to save energy. And this is a pretty exciting product that we've been talking to a lot of people about. So I thank you for joining us today. We have quite a few people here on the line, so everyone's going to remain muted for the duration of the session. But ultimately, we are here for you, and we want you to get the most out of this as possible. We've saved some time here at the end for questions. So as they come up, you can type them into the chat or the questions toolbar, and we'll be addressing those at the end. And with that, I'll turn things over to Tim, and we'll get going.
Excellent. Thank you, Dean, and thank you for joining today's conversation. I'm going to actually break this conversation into kind of two parts. One is what's changed within the ASHRAE community recently that allowed us to provide this new product to the market, and then what the new product is and how it actually solves this solution. To kind of set up the stage, many people know us for a handful of different other products, specifically around soft ionization and our coil cleaning product. But this is a new product market that we've created, and it's really around this idea of creating better systems around ventilation efficiency, and it's using the 62.1 indoor air quality procedure. And there have been some significant changes that have happened within that code, and that's what I want to address first as I kind of walk through that piece, and then I'll address what we've done. When you look at buildings as a total, what you generally see, and I'm going to speak just kind of high level on this, but generally commercial buildings consume 40% of their consumption of energy actually comes from the HVAC system. And if you look kind of deeper into that, roughly 40% of that energy is from your outdoor air conditioning loads. And so if you can actually create a system that has better ventilation efficiency on it, you can cut out a significant portion of the energy requirements for that building. In some cases, when you think about high occupancy load spaces, where the ventilation load is driving the size of that equipment, you could potentially save upwards of 7 or even 8% of the energy on that building. And that's not a small number, and that's also why ASHRAE has been really leaning into this concept. Additionally, when you think about where the ventilation load creates challenges for the construction side of the business, the equipment, the first cost side of that business, if I can lower the requirements on the ventilation load, I therefore then can potentially bring budgets back under control. We're seeing a lot of instances where they're using this method for jobs that have either had budgets that got blown open because of all the increase in costs that we see. We know steel is up around 22% right now, as well as other aspects of the market where the economy is creating this challenge for new projects to make it to the market. You're budgeting it last year, and now this year, all of a sudden, the budget has to get resized, or this job has to get de-scoped because of the size of these. The cost of everything has increased. And so thereby, if I can actually create better quality air and also help you save your budgets, now this becomes a really simple conversation for a lot of customers. To put this in perspective from an ASHRAE point of view, Max Sherman is a fellow within ASHRAE, and last year he wrote this paper called the IAQP paradigm. And what's interesting, and the reason why I bring this up to kind of kick us off, is this paper that at this year's ASHRAE summer event won the ASHRAE Journal Article of the Year. And so I highly recommend you go read it. And he speaks more about the harm that's created with outdoor pollutants and other pollutants that we breathe on a daily basis. But just quite simply, if you can lower your outdoor air or reduce the pollutant harm outdoors, that plays a very significant effect on our human health. And so you see here in that first top paragraph that I wrote, this comes directly from the article, but he says, look, source reduction, so outdoor pollutants, and air cleaning can greatly reduce the contaminant harm without increasing your ventilation rate, thus saving energy. He then goes on to describe and kind of the history of the indoor air quality procedure and how that came about. Came about in the early 80s. But more to the point, at the end of the article, he says, look, if you can focus on a combination of your source control, your ventilation, and air cleaning, that is the most practical way to handle a lot of these contaminants. And so there really is this concept that ASHRAE has leaned into, where they've recognized that the indoor air quality procedure is a better direct method for better air quality. And so the question is, why has it not really been applied as broadly as we see the VRP? And you'll notice here the statement from the ASHRAE-62.1 user manual that states the ventilation rate procedure. For those who are not familiar, that's the table that you go down, where you go down to a category and you typically see in there how much CFM is there per person, how much CFM do you apply per square feet, and then you divide it by the ventilation effectiveness, right? And so in that scenario, that's a pretty broad brush to designing for the ventilation load. And what it tends to be is a very indirect solution to indoor air quality, because you are pulling in all these outdoor pollutants in an effort to try to dilute what's in the space. And so it's a highly diluted process that requires a lot of air in these large ventilation systems. And it creates a very expensive system, which quite frankly is not really cleaning the air as well as we can if we simply just scrub the air. And if we can scrub the air, we actually not only create better air quality, but we can also improve energy efficiency. And if done correctly, we can improve the cost of the buildings as well. And so you'll see here also that they say, look, the IAQP may allow for a more cost-effective solution to providing good air quality. And so that's the point. And so then the question becomes, well, why hasn't it not been adopted? And quite frankly, the way that the system was set up previously, or the way the code had been written previously based on the standard, was that there was a lot of things that were left undefined that the engineer had to define. And so there was a lot of risk on the design side of the table, both for the manufacturer as well as specifically for the engineer. And so I'm showing you that here in this table. You'll see that historically, the design compounds, the limits to those compounds, the generation rates, all of that was left for somebody on the design side to actually figure out. And then we, as the manufacturers, would go test our products in the real world and then put together calculators and say, look, this is what we can do. Does this help what you're trying to do? And so you can see that's not only a lot of work, but it's also a lot of risk. In the 2019 standard that's now been adopted within, broadly across the New England market now, and then obviously in 2022, what ASHRAE did was they said, look, we understand enough where we can standardize all this. And so they've added in all the pieces, a lot more of a prescriptive standard, very similar to how prescriptive the VRP is. And then in concordance with that, they also added a calculator. So they built a calculator that you can simply, we at GPS for smartIAQ launch also created our own calculator that adds a couple other things to make it very, very easy to apply our products and design systems. And so that then leads to, if we can reduce the risk, can we also now just simplify that adoption and accelerate the adoption of the IAQP in the interest of decarbonization and in the interest of all the electrification needs that are across the market? And so let me kind of show you now one of the key components are within that code that you guys have now within your New England codes. And what you'll see here is they've now listed the design compounds. And so to the left of that table, I'm giving you kind of where these compounds are created from, where their sources are. And if you notice, PM 2.5, I mentioned that in that article that Max Sherman wrote and in a few other areas here now, but that's primarily coming from outdoor pollutants, right? These are small submicron particles that are coming from all sorts of things, whether they be dust, debris, car byproducts, what have you, construction. But primarily, you'll see high levels of PM in bigger cities or in cities in general. And so in these industrial areas, you get high levels of PM coming in. And you can imagine trying to dilute the space, you're still getting high levels of harm on that PM side. Additionally, notice formaldehyde is a building off-gassing, right? And so that off-gassing happens because of all the buildings, furnitures and paints and glues that we put into our spaces. We spend a lot of time in these spaces. And so they added, look, these are the VOCs that we as occupants actually emit through metabolic processes. And so now that kind of brings you up to where we saw an avenue that said, look, we can build a really good product that meets this need, but also do it in a manner that provides the side of the equation. And so quite simply, for every dollar you spend in smartIAQ, what we're seeing is about a $4 to $8 in savings on the upfront equipment cost. And I'm going to show you some business cases that kind of points to that, but it's quite significant. If you open up our unit, what you'll notice is we have an air quality sensor on the inlet side of that unit, and we're measuring the quality of the air. And then as we see that air quality coming out of control, we ramp up our ECM blower there that you see that's listed as number 3, and we pull more air through our filter kits. And so I'm showing you here a filter kit. We can obviously design and set up any type of filter kit you need. So we have a healthcare kit. If you need it gasketed, we can gasket it. If you need more, if you have a particular contaminant, we can design it for that. But what we wanted to do is make that not proprietary. So those are commercially available filters that you can go buy anywhere. But we gave you the flexibility to either buy it through our representation like we have here in Buckley, or you can go out in the market and find it. But the point of our unit was to meet the standard. And so as we bring in air, we clean it to the standard, and now we discharge cleaned air. You'll notice here is a very simple way to install this unit. I'll show you some more complex ways. But as you're bringing in the air, we're cleaning it and we're discharging it back. That's quite simple, but here's the kind of aspect to this that offers a nuance that's quite unique. Because this is decoupled from the main system, you now can offer a system that has smaller ductwork, obviously a smaller HVAC unit as well. And it provides for you better control of the space. One of the statistics I recently read stated that 65% of our commercial spaces are overventilated. This is a classic scenario in schools, right? Schools are high occupancy zones where the ventilation load is driving the size of that equipment. And so you have this challenge where you're constantly heating and cooling in an effort to try to find good homeostasis for the load of that space. But independent from that, while you're actually managing the load of that space with the system, our system will manage the air quality of that space. That's very unique. You normally don't have that. You're normally trying to manage air quality with the load requirements of that space. We do it in a decoupled fashion in this manner so that you can drive these independently. Here's another way to set it up. You can tie it as a centralized system. This offers you a much more economic value where we'll clean the air as it goes by. So think about your bigger systems, your high volume based systems, your theaters, your conferences, your gyms. Those are the types of areas where you're going to be moving a lot of air through it, and we can clean it as it goes by. And then maybe a last set and some more value from an economic perspective. One unit can actually offer a broader array than just one room. And so what we think about it, if you think about that classroom as one example here, I can put a unit in the ceiling of a hallway, and I can serve the 4 classrooms that it surrounds quite simply. And so what we've done as part of our design is we designed into the unit an external static capable of up to 0.8 inches. And so now you have the flexibility to run ductwork and you run diffusers and the like, but we'll independently clean all that and make a space very, very clean, even more so than what you might have with high volume ventilation loads that you're historically designing to. And so if you think about a wing of a school, let's say, or a wing of an office, if you have 8 classrooms, 2 units would be all that you would need to solve that. And so now you can see that economic value where you can really lower the cost of the units of the main system, and you're not adding in a lot of cost back into the construction budget. So what makes our unit intelligent? Why do we call it smartIAQ? Well, quite simply, it's our ability to do this, what I call closed loop monitoring, right? We're measuring the quality of that air constantly. And what are we measuring? We're measuring TVOCs, we're measuring CO2, formaldehyde, NOx, and then 4 levels of particles, PM1, PM2.5, PM4, and PM10, right? And so if you think about that PM1 or your sub 1 micron particles that we learned all about through the pandemic, whether they be, extreme small dust or viruses or what have you. PM2.5 is a typical dust outdoor pollutant measurement. 4 and 10 relate to broader, bigger items like pollen outside and allergies and the like as well. Okay, so we're measuring that full spectrum, and we're giving you a really good indication of the quality of the air that's in the space. What's important about that as it relates back to the code is now you get a really good picture, and it hits all the buckets that ASHRAE has designed for and they want within the indoor air quality. When you read the IAQP, one of the things it talks about is they want an assessment of all the contaminants, not just the contaminants related to occupants. And so for that reason, we can measure what's happening with the building off-gassing, principally through formaldehyde. We can measure all the pollutants that are coming in from outdoors, whether it be smoke or vehicle exhaust or what have you. And also, obviously, the bucket related to occupants that are generated. That now gives you a really good picture of how clean your air is. And now you can understand why they said in that user manual, this is a more direct approach to the goal of air quality. Okay, so how does our system operate? Well, if you did not want to tie this to BACnet or Modbus, back to your BMS system through BACnet or Modbus, we can operate independently, put into the intelligence of the unit a manner by which it can operate on its own. And so if you start on the left here, you'll notice idle mode. Where no one's in the room, it's going to notice that the CO2 is at background noise, or basically equal to outdoors, and it will put itself into an off position where it kicks on every 5 minutes and will measure the CO2 in an effort to see if CO2 has risen. As soon as it notices somebody's in the room through the proxy of CO2, it will kick itself into a refresh response. And that's kind of a cleaning process by which it will immediately get the room ready and really clean that space to get good air quality within that space to get started for the day. And then it moves to monitor mode. And that's what I call that sniffing mode. It's a very light, low noise, whisper quiet mode where it's just going to monitor the space. And then as there's contaminants that it sees rising out of control, it too will proportionately rise in an effort to manage those contaminants. And it will run until the contaminants get back under control. And then at the end of the day, when everybody leaves, the CO2 will fall back down, and the unit will put itself back into idle mode. So it's a very it's giving you the best, longest life of the filters that we can offer. The filters obviously are what makes this meet the standards exactly. And so as part of the standard, there are 2 tests that we had to run with our unit. The first test is quite simply, most people know it, but it's for the particles in the air, and that's related to 52.2. And so in our basic kit, we offer a MERV 14 2-inch thick, deep pleated panel rated at 50 for the 52.2 rating. And then additionally, we offer a molecular filter that's been substrated for aldehydes, and it's also got carbon in it to handle all those other VOCs in the air. And that had to meet a test known as 145.2, which is relatively new, and what really pushed this into the mainstream, if you will, of acceptance, why the articles are being written. It also now is adopted. This standard, this IAQP has now been adopted under USGBC's LEED version 4.1 and now version 5. All of this is because now they can see, hey, look, in the interest of decarbonization, but also in the interest of better air quality, we can do this where you apply the right sets of tools and the right technology that meet the right standards. However, if done in the way in which we're managing it, we can extend the life of those filters for greater than a year. And so as you can see there on the bottom, these are standard filters. You can go out in the marketplace and find them yourself. but we'll also offer these in kits. And so as we work with our customers and we work with challenges, we have a basic, what I call 62.1 kit, but we also have a 170 kit for healthcare. And we'll have kits that meet all certain requirements that we can go procure different filters. So this becomes a really flexible play in the interest of decarbonization, but also more so in the interest of air quality. Okay, so that brings me up to now. Let me show you this in practice. Let me show you where this really applies as it relates to savings. And I'm going to talk a lot here about first cost savings, but I'll point a little bit to energy savings. This is a church that happened to be in Texas. You could see in that third column, we were able to, because as you can imagine, again, large places of assembly, a church obviously has a big sanctuary in other places, where we were able to provide a reduction of outdoor air around 50%, which came to a reduction in the equipment load of about 76 tons. And you could see just dollar for dollar on the equipment. This doesn't include ductwork, simplification of ductwork or smaller ductwork, or it doesn't include any of the installed reductions that you got on the construction side. But just dollar for dollar on the equipment, you see $172,000 savings. In addition, we saw an additional $20,000 of operating savings or energy savings in the year-over-year approach. That gives you a benefit of $192,000. Again, that's quite significant. This happened to be an email that we kind of pull out, but I'll speak to the example on this. So an engineer was working on a value engineer job where the job itself was just was just over budget. And a lot of it was due to the fact that ventilation loads were quite large. And they were asking if we can remove the wheel. And obviously there's requirements for energy recovery under 90.1. And so we worked with this engineer to actually help address this large kind of, it was like a trampoline park, adventure park, if you will. And so again, large public place of assembly, but we were able to reduce the wheels in all 9 of their units and replace them with our equipment, our smartIAQ unit. So 1 unit for every wheel effectively is how this worked. And we saw a net of over $100,000 of savings on the equipment side of that, not to mention all the operating savings that you get as well. And so again, simplification of equipment, meeting the code, making this a very simple approach, and a more efficient ventilation system. Let me talk also about retrofits. So in this instance, this was in Jersey City. It's about a 20-story building that was an office building, and they were converting that first floor into a private school. And again, the calculations were such that the ventilation loads were going to require that they rip out the louvers. In one case, they were going to have to rip out a door they were talking about and rip out the wall. They were going to need bigger ductwork. So this was creating a lot of construction costs that they weren't planning for. And so our rep walked in and said, look, we can keep all that and just clean it instead. And so long as you have enough air for pressurization and exfiltration and whatever other needs you need, we can manage the rest of that. And in fact, in this particular instance, we were able to put 1 smartIAQ unit on each of the water source heat pumps, and there were 2, and then we put 1 in their gym. And so 3 units solved this entire problem and actually saved them on a lot of that construction cost that was going to happen, both on the demolition side as well as on the new side. This job happens to be just north of us here in the Greater Toronto market. This was a university. They had a theater that they were expanding. And the existing DOAS unit was sitting on dunnage, had a certain electrical supply to it and so on. But they were expanding the theater. And so the engineer was trying to figure, the unit got so big that the dunnage was going to have to get upsized and get reinforced. It was going to have to require new electrical service. They were going to have to provide new duct penetrations. And when I sat with the engineer, he said to me, hey, you actually saved this project. Meaning the project itself was blown open. They were trying to figure out if they were even going to be able to move forward. And so instead, size your unit the way you had it, and we'll clean the rest of it. And we ended up only needing 1 unit on this particular job. But you can imagine no increase in dunnage cost, no increase in electrical service. They've effectively swapped the DOAS like for like. No increase in duct penetrations, right? All of that is additional savings that you get simply because you're lowering that ventilation requirement and you're instead cleaning the air. Yet another on the modernization side of this was a retrofit that was happening where it was a very large school and they had ductwork, but the ductwork was going to be too small for the updated ventilation loads as they were updating all their facilities. And so the contractor came back and said, look, the cost to replace this ductwork and install new was going to be $300,000. And so my rep walked in and said, look, again, we can offer savings here, worked with the engineer on the redesign. And in fact, we were able to show reductions in the systems as well, the rooftop units. So the rooftops went from a 15-ton applied system down to a 12-ton light commercial system. And so net, we were able to save the whole project around $400,000. And then my last one here that I want to address, this one happens to be around a utility credit and working with a utility company. So this project is currently right now still in design, but I think it's an interesting one to the point. I've actually just came from another conversation yesterday with another energy company. And so we see a lot of value here that I think can potentially oftentimes get overlooked. You can see the floor plan here, quite a large footprint for a building, and it's 8 stories tall. And the story is that this building runs 24/7, and it has a 60,000 CFM DOAS unit that needed to get replaced. And so we worked with both the customer and the utility company as well as with the engineer. What we figured out is, look, you don't need all that extra outdoor air, and we can lower the outdoor air in a way that actually provides you significant savings on the DOAS unit itself. And so that DOAS unit went from roughly about a $1.2 million, $1.1 million unit down to about a $600,000 unit. So significant savings there, but even more to the point, the energy that we were going to save, the utility company said, look, we can easily write probably more than, but for the purposes of today's conversation, the energy credit was upwards of $280,000, which was going to then fund a lot of this project. And we're solving this by basically cleaning all of these with multiple units in each of these floors. So that provides some perspective on where we see really good value. One of the things to think about when you think about the ventilation rate procedure versus the indoor air quality procedure is, where do you want to apply this? And I know today oftentimes the way the calculators run, whether it be HAP or Tracer or one of those, you simply run a ventilation load calc and it's just doing basically the VRP. But now what you have is a tool that you can say, look, you don't, on the same job, you can offer the VRP in some areas and you can go get energy savings with an IAQP in other areas. You don't need to one carte blanche across the entire project. And so you can look at this in segments. And there's value, as I've shown you, where the indoor air quality procedure has enormous value. We see it in auditoriums and in gyms and in places of worship, as I've shown you. But think about your banks, think about your libraries, think about your schools. A lot of these places that have large loads where the ventilation load is driving the size of that equipment, there's an opportunity for offering a more efficient system, and thereby meeting some of these energy stretch codes that are being required within our communities. There's an aspect of this also where you can also help, where you are returning air, you can help improve some of the challenges you might see on the humidity as well as air side, because you can improve the mixed air temperature when the temperature is extremely hot or, quite frankly, extremely cold. And so we see value there as well in some of these extreme climate markets as well. So I would ask that you look at this in those particular markets and connect with us and connect with Buckley to kind of simply put the calculation in perspective. I'm not going to go through the calculator today. We're more than happy to send it to you, and we're more than happy to show you it. But that calculator is really simple to use. But even more simply, we have on staff application engineering team. And so we're working with engineers today where they'll send us the project, we'll run the calculation for them, and then we'll get everybody on the phone and kind of walk you through. This is what we see. This, if we heard you right, this is what you need for pressurization and exfiltration, and this is what we can offer. And then we talk to them about designs and so on, and our engineering team can help. We have schedules, we have specs, we have CAD files, and all the things you would need to actually create a simplified drawing. But our goal really is to make this very simple and easy to use. And so we offer this as a free service to try to help with this idea of adopting so that we can save energy in our buildings and in our future designs. If you are at all interested, I would highly welcome you to come join us. We have a living lab and experience center that we have engineers coming to often, as well as customers and contractors. In fact, we're doing another experience, I guess, next week with a host of people coming in from around the country. And so that's also available to you. It's an open invitation. We'd love to entertain you. We have a bunch of labs in our space where you can meet with our engineers, and you can see what we do to create all of these unique products that address not only the outdoor air, but also do it in a manner that can provide you really good energy savings. Lastly, real quick, I do want to address, just on the interest of energy efficiency, I just want to address that there are some things that we offer that are tandem to this. And so as you think about things like, can I also provide ways in which I'm can clean coils, we offer a coil cleaning solution as well. Think about your deep row coils where you get mold and biofilm on that interior side of that coil. Our solutions actually can provide that. And so this works really well with the smartIAQ as a full complement solution. It also addresses outdoor pollutants. So we see this a lot for problems with outdoor air issues for helicopters and airplanes, as well as idling trucks and cars. It's effectively all addressing the same component known as BTEX, butane, toluene, ethylene, and xylene. And so we have a lot of applications here in this market. Boston Children's Hospital is a really big customer for us on this. They've seen a lot of great value. And to kind of highlight this quite quickly, this is a deep row coil. It's about 18,000 CFM, where we did a year-long study on it. And what you can see is the coil started at a static of 0.45. That was its design. And then quickly, as it condensed water and was cold and is wet inside, it started obviously growing biofilm. And so you can see it started to rise. And then when we turned on our unit, you could see we slowly started to bring that unit back under control. But more importantly, we were able to control that unit for the rest of these kind of several months that we monitored it, such that we kept it clean. And so I offer you that as part of all the things that we think about when we think about ways in which we can provide healthier, more efficient, and resilient spaces. Our goal at GPS Air is to provide to the marketplace really good energy efficiency ideas that meet the standard and that can really help you with ideas that you guys are trying to provide for healthier air, better living environments, and the like. And so with that, that's what I had to talk through. I know there's the chat feature here, so give me a second and I'm going to switch my screen and bump and go over to the chat feature. Here we go. If there are any questions, you're welcome to either come off mute or you're welcome to add them to the chat now. Right now, I don't see any. So I'll open it up for the line if anybody has any questions. No questions.
Next to chat, is there a box that has?
Yeah, no questions. Yeah.
No, click that. What's that?
This is chat, and this is the questions.
I've got one.
Okay, if you want to read it. Sorry, I'm not seeing it on my end, but I'm being told there is a question, so give me 1 second.
Tim, can you hear me?
I can.
Okay, it is a question from Lyndon Pizanski. Can you integrate these systems into an already decoupled system, such as with a decoupled FCU system?
Yeah. So, Linda, that's a great question. We would address that in, I'm going to call it 2 ways. Depending on how big your system is, if you're bringing air to offer, let's say that FCU is doing a bigger wing, we would do it in accordance with that. I think I'm still sharing my screen. We would do it kind of similar to how I showed here with our return system design. But if you wanted to actually do it separately, we can run it separately, where that system, your fan coil unit, might just be providing air, and then you have maybe it's a DOAS system that's being provided from. In that case, we would run it in a more distributed model like I showed in this particular slide. And so typically what we do is we work through, first we do the calculation, so it's just kind of a numbers decision. Okay, does this make sense on a numbers basis? And then we talk about kind of the application and installation of it. How might you go about solving that? And so we know we have these kind of tool sets in a way to apply it, and then we apply it accordingly. Oh, now I see that question. I don't know why I didn't see it earlier, but now it's come up. Are there any other questions? Okay. Thank you so much. I really do appreciate the opportunity to present this webinar. For those who are interested and would like further information, or you like more content related around the indoor air quality procedure and how we solve it, please by all means reach out to us. I'm happy to share a lot of information. You can find a fair amount on our main website. Just go to gpsair.com and click on smartIAQ, and we've added a bunch of material there that actually pertains to how ASHRAE is written around this, and then how we're solving it. So with that, thank you guys. Really appreciate the time and the opportunity to present. Take care.